Start the clock again.
Carol, we've got the new logos for the Baton Rouge. Have you seen the new logo? John just redid it.
I saw that with the ring around. It looks very nice.
Yeah. Did you see the one with the gator?
Yeah. Is that cool?
I like the colorful, the lime green. The colors really jump out.
Yeah, they really are. They really are. Good contrasting with the rest of it.
Yeah, it looks nice.
Yeah.
Everybody, now that we've got, it's like, Albuquerque's only, a couple weeks behind us or a week behind us.
We're already changing the focus now. Yep.
Yep, definitely so.
Things takes a whole year.
Had a good meeting last night.
Yeah. Yeah, Scott, you did an amazing job. I've heard so many people that have watched all your interviews. I've heard so many good comments.
Well, that's good.
And the Albuquerque people, the people I ran into in the airport, all they wanted to do was say how much they appreciated it. They really liked the meteoritics when they went to the museum, because one couple said, I expected to go to a museum and just look around and walk around. And they said they took them apparently into the lab and actually showed them analyzing a sample. And they said it was incredible. So,
hidden gem there, apparently.
Yeah. Very hands-on. And Harrison Schmidt, oh my gosh, he was amazing.
Yeah, he was cool.
He was one of the nicest people, and his wife was just amazing.
Yeah, that's true.
He's totally up with what's going on in the world of space and astronomy right now.
Yeah, he was really sharp. You're not going to pull the wool over Harrison Schmidt's eyes, that's for sure.
That's true.
No. And everybody enjoyed Seth's talk too. Seth.
Oh yeah.
He always makes you laugh. Oh my gosh.
Yeah. His timing and everything is just really incredible.
Yep.
Space weather. So this is going to be also a good program for space weather, I think. So.
Did you see the thing about Betelgeuse, however you want to say it? Oh my gosh, Bob must have read it too. That was amazing. Now we know why it dimmed down.
Yeah, I didn't know any of that until I saw it this morning.
Me either.
I haven't seen it.
You haven't seen it? Check Space Weather.
No.
Oh, it's amazing. What happened with Betelgeuse? Or Betelgeuse, however.
This might be a reason.
Well, that's true. That's true. But I mean, it is amazing. I never, the sun always has CMEs, but I never really thought about a star having, and it wasn't a CME.
I've never before seen massive eruption. So that was why it dimmed so much?
Could be. I don't know if they know for sure,
Massive stellar eruption, the likes of never before seen, according to astronomers.
So from what they said, it wasn't the corona that erupted. It was a part of what we would call the photosphere that was ejected. And then it went off into a cloud that blocked, just like anything else, it absorbed the light from Betelgeuse and made it dimmer, according to their theory. But
that was a huge amount of material.
So we already have some people tuning in. We got Tarek from the UAE. Charity Rose Walker, she said, I've had a bit of drink and should remain silent. Okay. All right, Charity. Okay. And we'll have some more people logging on here in a little bit. For those of you who are watching, please share this program. This is outreach from the Astronomical League, and we got some great speakers on today, so. And here we go. Well, hello everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and we are with another edition of the Astronomical League Live. I'm going to bring Terry Mann on with me. Now, if I could just get my camera aligned on myself, I guess that might help. Here we go. Terry, how are you?
I'm doing fine. How about you?
I'm okay. I was racing all day long getting ready for things, but I think I was able to do it. So
Yeah,
it's been good talking.
Good.
Yeah, I love the kind of the backstage chatter that we have before we do these shows. So I guess let me show everyone that's on right now. We've got Terry Mann, Secretary of the Astronomical League. We have Bob here with us, who's going to give our keynote. Steve, Carol Orge, who's the president of the Astronomical League, and David Levy, who is en route to somewhere but live with us now. So, Terry, I'm going to turn this over to you.
All right. Thank you, Scott. Well, it is so good to be back from Alcon. It was an amazing time, and it was great to meet so many people again. It's so nice to look people in the eye. You know, I was also down at Green Bank for StarQuest and got to see Steve and Bob down there, but just to be with people again and talk and just laugh instead of this is great. I'm glad we had Zoom, but being there in person is really nice. So with that, how about David, if I go to you and you get us started off with one of your beautiful quotations.
Well, thank you, Terry. And it's wonderful to be here, as brief as it must be, because I'm trying to talk the police officer out of giving me a ticket. So, no, I'm just kidding. Anyway, before I do the quotation, which is going to be one you've all heard before from Romeo and Juliet, I have a couple of announcements and concerning sad things that have happened. One of them is that 2 days ago, Don Mockholtz passed away suddenly from COVID, and in the middle of the night. He was the leading visual comet discoverer in the world, and it's really a sad thing to lose him. But last night we lost Konstantin Papakozlas. He had been in declining health. He had a bad stroke and another bad stroke, and we think that he had a third one last night, which cost him his life. Konstantin has attended more cellophans than anybody else, I think, in the world. I think he's attended like almost 60 of them.
Wow.
So my quotation today is from Romeo and Juliet. Come, gentle night. Come, loving, black-browed night. Give me my Romeo, and when I shall die, take him and cut him out in little stars, and he will make the face of heaven so fine that all the world will be in love with night and pay no worship to the garish sun. Thank you all very much. And Terry, back to you.
Thank you, David. As always, we really appreciate you being here. Good luck with everything, and you are in our thoughts.
Thank you.
So with that, how about Carol, if we kind of touch base with you and you can fill us in on everything that's happened this month.
Well, this has been an exciting 2 or 3 weeks for the league. We just got back from Albuquerque and our convention there. I have some news to report. from the Observing Award section of the league, and that is that we have two new awards that were approved this year. One is called the Solar Neighborhood Observing Program, and the other is called the Bennett Observing Program. The Bennett Observing Program makes an accommodation for our South America astronomers as far as some of the award programs that they can participate in as well. So we're very appreciative of that, and more information will be coming shortly on that. One of the important things we did at Alcon was honor 13 new master observers. And out of those 13, surprise, surprise, about 3/4 of those were from the local Albuquerque Astronomical Society. It really helps to have those wonderful dark skies when you can go out most nights and not have to fight clouds like we do in the Midwest and other portions of the country. So that was a real thrill to get to present that many Master Observer Awards at the meeting. And we had a spectrum of other awards, including one of our newest awards. That's the Fleming Imaging Award, sponsored by Scott Roberts. And it's a 2-year-old award, and it has really taken off. We had a tremendous number of good entries this year. And there's something in the league hierarchy for everybody as far as awards that can be presented. Another new thing we did, and we alluded to this just a little bit before here, and that was thanks to Scott Roberts and Explorer Alliance, we did quite a bit of streaming with interviews and that sort of thing. And Terry said earlier, it went over very well, and it got people's attention wherever we were as we travel back home. The one thing that the executive committee has been discussing after that is the possibility of having the streaming feature at next year's Alcon 2023 for Baton Rouge, Louisiana in July. And there's been enough interest expressed that we are thinking about having that option as far as the streaming for the whole convention, including the presentations that are given. Many of our organizations are already doing registration for the live event online as well. So we're attempting to do both tracks, both the in-person event, which is wonderful, but sometimes for many reasons, people can't attend our national convention. And that's where it comes in real handy if we're able to stream that, and they can have the same benefit for a token amount of registration fees. So we're looking at that very carefully. Another thing that was noteworthy, in addition to the great job that the local club did in hosting Alcon, they did a wonderful job. They were very helpful to our guests, and we appreciate that very much. The other thing we did, we had a diversity panel at this year's Alcon, and we tried to define what diversity was all about. And we didn't come up with just one definition for diversity. But one of the things we found during the pandemic, and even before in many ways, is that there are many people in our country who don't have access to astronomical resources at all. Whether it's being in an inner city, whether it's in rural areas, we have found that we have a major audience that isn't able to avail themselves of opportunities. So we kicked around several ideas at that panel about ways we might be able to close the gap a little bit and make those resources more readily available. It ran the gamut all the way from possibly piggybacking on the back of local libraries across the country that would have access to remote telescopes and all things in between. So we really are looking at many things that might allow us to make some changes there. Another thing that we talked about, one of the suggestions was this wasn't directly about diversity, but it was the mention that we need to expand our use of the YouTube channel we already have on the League webpage to include maybe some how-to videos about observing in general, and maybe specific programs, maybe some hints on how best to maneuver through those processes. So that's, I think, will be a big plus as well. And let's see. That's about all I have as far as upcoming programs coming up. As I said earlier, next year's convention, mark your calendars now for July 26th through July 29th in Baton Rouge, Louisiana. They're well into the planning mode there, and we've had some meetings just recently, and they're excited to go forward. They have some wonderful, great trips planned, side trips planned, and I think you'll enjoy it. So back to you now, Terry.
Okay, thank you, Carol. Yeah, there's a lot when somebody is planning Alcon, it takes quite a bit of time actually and effort to get everything put together. And the Albuquerque Astronomical Society and Jim Fordyce did a fantastic job. So, we are all extremely grateful for all of the work they put in and everything they did. It was very nice and a lot of good compliments. And I'm sure Baton Rouge, now we move to that, and it will be the same. It seems like with every Alcon, it has its own personality. Wherever we go, whatever city we're in, we see new things. We meet new people because people from that area tend to be there. And, we go to different areas. We meet new people and meet old friends. So as Carol said, please mark your calendar for the end of July. And it is air conditioned. There'll be plenty of air conditioning. So we'll be inside, and please join us in Baton Rouge.
And that's actually our first trip to Louisiana for a national convention.
Is it?
Yeah.
So wow.
We're excited about that. We think it'll encourage a lot of people within the several hundred miles to visit. So.
Yeah. And as my sister pointed out, the beach is only like an hour away. So I think my sister might be joining me there. So a trip before or after Alcon.
That might come in handy, the beach.
Yes, that's my sister's a beach person. So yes, join us. So, all right. I am going to, we always ask 3 questions and give away 3 door prizes from the Astronomical League. So I am going to do that in just a minute. We are going to we need to discuss something because we have found with the national office, we have had problems with international shipping that you have heard me talk about before. So I'm going to discuss that just a little bit.
Good luck.
And there we go. All right. So tonight's door prize, 3 winners will be drawn. And this isn't like the GSP. Tonight we need to answer them as quickly as possible because I will announce the 3 winners before the program is over. So 3 winners will receive a 75th anniversary pin and a 3-inch round AL logo magnet. Now, we are going to temporarily have to stop international shipping until we figure out the best way to do this. We ran into an issue last time I gave away the tote bags. The tote bag is a $12 value. By the time it was shipped to another country with all of the imports and fees, it was between $60 and $70 for the $12 tote bag. Until we get this figured out, please, we're sorry to do this, but the cost sometimes goes back to the person that won it and sometimes to the office. And that is it's not acceptable for what we're doing at this point. So the office right now is trying to find, a way to ship, how to do this where, it's more reasonable because each country apparently has their own schedule of shipping and taxes and fees. So it's getting very confusing for our national office, especially when things comes back in a month or 2 being rejected. So for right now, temporarily, we are halting international shipping while we look at this to see what we can do. So I'm sorry, but for right now, that until we figure it out, that's what we're going to have to do for the office. So let me go on. I'm going to ask 3 questions. And like I said, please answer these questions in the next 30 minutes if possible. Winners will be announced after the last speaker, and someone from the Astronomical League office will contact the winner. And if we find out it's international, you're an international winner, the office will probably explain to you just exactly what I explained now. So just be aware. So, questions for tonight. Remember, please send your answers to secretary@astroleague.org. Okay, first question. What is the name of the Curiosity landing site? So what name did they give the landing site where Curiosity landed? And again, secretary@astroleague.org. Second question. In what constellation is Comet Pan-STARRS located in on September 15th? And again, secretary@astroleague.org. Please send your answers there. Third question. When Saturn's rings will be at 14 degrees open at opposition on August 14th, how many years will it be before the rings are open enough to reveal this kind of splendor again? So Saturn's rings are open at 14 degrees at opposition on August 14th. How many years will it be before the rings are open enough to show this kind of beauty again? And please send your answers to secretary@astroleague.org. And for right now, I'm going to stop that right there. And Steve, are you about ready to start?
Yes, I am.
Okay, Steve, I'm going to turn it over to you. Let me introduce Steve a little bit here first. Steve is a AA VSO mentor, and he is very active in the Astronomical League. He is an advanced master observer, a binocular master observer, a master imager, citizen science planning committee. He's a program coordinator with the League. With the astronomy before the telescope, radio astronomy, spectrography, and foundations of imaging lead author. And needless to say, he's hopelessly addicted to the Astronomical League observing programs. Steve is a very knowledgeable person that we've ran into each other on the observing field at StarQuest many times, and much appreciated. Full of knowledge, and that's what we really like. So Steve, if you would, take it away.
Let me make sure I'm sharing the right screen.
Okay.
Should be that one.
That's it.
Let me, come on, get out of the way. Slideshow, you show. I'll start by saying that if anybody out there in the audience wants to follow along, I've posted online 2 different links to this PowerPoint presentation. And the truth is, if you would like to download it later and share it with your local club, that's just fine with me. Feel free to do that, edit it. I don't have my name in there anywhere, I don't think. So it's pretty clean, and you can take care of it that way. I would say truthfully that this PowerPoint started life about 2 months ago. I take care of the observing kind of things that go on with the local club here, the Astronomical Society of Eastern Missouri. I'm in St. Louis. And ultimately, in talking with people, a lot of times people are afraid to get into doing Astronomical League observing programs just because they don't know how and they don't know what to do. And logging is sometimes one of the hurdles that they have to go across. They'll go to the website, they'll see the requirements, but they don't know what else they need to do. So that was the idea behind this PowerPoint. Ultimately, one of the major questions you're probably going to ask yourself is, why should you keep a log? And really, to me, there are 2 different reasons why you should do it. One is for personal, what is it going to do for me? And then obviously another is, for what you have to do the Astronomical League program itself. I'm not going to insult you by reading out all this text right here. You can read that on the screen. But while that's there, I'd like to point out, I'm approaching 73 years of age. I'm not as sharp as I used to be. I used to be able to remember things forever and ever. logging is a good way to, in your later age, be able to remember things, to be able to go back and say, oh, well, yeah, 10 years ago I did that. I saw that. It was at this location, and this is what the weather was like, and this was who was here with me. Logging is a good thing to do, particularly if you have important things you want to remember. I'm a fiddler. I like to change hardware. I'm a computer person. I like to mess with stuff. And by logging, I can have a way of going back and looking over and saying, well, yeah, that's how it worked. Now I know how to do it and to set it up. Okay. So one way is for personal. And truthfully, personal logging is like doing a diary. And there's people in this world who think doing a diary is the most wonderful thing. Well, obviously, the other way is to keep stuff for an AL program. And that's really what this presentation is about. And so I asked myself, well, why should you have to log as part of a program? Well, one reason, I'm a retired school teacher, and we always wanted kids to be able to document, to show whatever it is they're doing. And so ultimately, I have a feeling that years and years and years ago, make it sound long ago, last century, when people first started putting together Astronomical League observing programs, they wanted some kind of document that would prove that the people out there in the field were actually doing what they were supposed to do. And so that's the purpose of the log. And another truth, if you really look at things like Messier marathons, those aren't in the spirit of doing an Astronomical League program. And truthfully, they're just like, put a check mark. Yep, been there, done that. 5 minutes is about all the time you have to do the marathon per object. Ultimately, you should probably look longer. So one of the reasons the AL has you log is so you can observe detail, so you can really see things, so you can manage them and do that. A truth is, a lot of times people think that down at the bottom there, that all they can put in their log is what the AL asks, and that's not true. I mean, make it your own. Put things in there that you want to have in there that you can remember for later. I would ask a question of anybody out there who's completed an Astronomical League observing program. Would you want to go back after 5 years and read your log? Put things in there that make it worthwhile, that would make you want to go back and say, I want to see what I did back there when I worked on the radio astronomy observing program.
Steve, can I interrupt for just a minute?
Sure.
Are you advancing slides?
Yes, ma'am.
Okay, you're still showing as being on the first slide, or at least that's what I have. Is that what?
That's the same for everybody else?
Yes, that's correct.
Yeah.
Well, that's just a problem.
There you go. Now you went one.
Yeah. I hate to think I have to do that this way. Okay, so anyway, let me point out and say, go back one more slide. You can see this, right?
Yes.
Can you see slideshow, view slideshow? Boom. Did that change?
Nope.
Okay, we're going to do this a different way, I think. I apologize. I apologize.
Now shifted.
I'm going to stop sharing, and I'm going to try a different way of doing this. Go here. I apologize. I talked to myself. Thank you for doing that, Terry.
No problem. I couldn't quite see the other slides, and I wasn't sure if you meant to advance them yet or not.
Hey, Steve, were you using the up and down arrows there on your keyboard, or are you using your mouse?
I think I was using a combination of both.
Okay.
But anyway. Slideshow, where does it say slideshow? There it says slideshow right underneath my picture. Let's try this one. Zoom.
Okay, Steve, you are muted right now. You need to unmute yourself. There we
Now
go.
can you hear me? I am sorry
Yes.
to make this fool of myself.
It's okay, we've all done it.
Yeah, been there.
Can Can you see this screen for the very, very first time?
Yes,
Okay.
YAL logging. Mm-hmm.
Okay. So we're good. If you were to prowl the Astronomical League's webpage, they have a section in there that's devoted to the logging kind of process. And I've included here the URL up here at the top of the page if you would like to search for that. But ultimately, they say to us essentially, what makes a good description? And it's got all these kind of reasons down here below. And they're all true. They're all things you should really be concerned with. It makes you a detailed observer. You're looking at it. You're not just saying, oh, yes, got it done. It makes you a better observer if you log. You have to practice doing it. It's not something that comes natural. It literally is something that requires effort on everybody's part. And ultimately, it's what you see, and it's going to make it different versus what somebody at the next pad might be doing or something like that. Okay, I'm going to try the space bar. As you log, okay, this is from me, and these are things that I think are important. I think you should always keep in mind the program's requirements because different programs require different kinds of things. Admittedly, a lot of the observing programs are patterned after the Messier program, where it would be the time of observation, the date, seeing transparency, and that sort of thing, and then a verbal description of what you're seeing. But other programs can require different things. And if you don't read the requirements in advance, you may skip something like the Shapley-Sawyer classification for the globular cluster program, or the Trumpler classification for open clusters. There are a number of things that you need to do with the planetary nebula program. Can you see a central star, and those kinds of things. So read the program's webpage to see what it is that you really should be putting down. And the second thought about that is that as you put those things down, you consider about how you are eventually going to report that to whoever you submit that to, whether it's the AL program coordinator or if there's a local person who you deal with. Ultimately, it says it right here, you plan on doing it by paper, and you could send it in, but that might require a whole lot of Xeroxing. Do people still Xerox, on your part? Do you want to do it electronically? Electronically is the way most people, I think, are doing it now, by sending either a PDF or a Word document, or even I've seen PowerPoint presentations. I personally do it in terms of web page, but a lot of people rely on email, and there is a problem if your email gets too big. And truthfully, I had a guy last week who submitted a log for the spectroscopy program. I think it ran somewhere in the neighborhood of 110 pages long and something like 20 meg or something like that. And truthfully, if he'd have sent that as an attachment to his email, it probably would have had some problems. So consider doing it through some kind of shared online directory. However you plan on submitting it, however you plan on doing it, trying to make it easy for the poor person like me who has to look it over. I've got a friend locally here who is the Foundation of Imaging Coordinator. And I know that he's had some stuff where people will submit some parts as a text document, but then they'll have the images for it somewhere else. And the bounce back and forth is really, really kind of a problem. So think about making it easy. This is a school teacher, retired school teacher, and me talking. Make it easy for me to grade, okay? If you look at the Astronomical League program's web pages, each program has a different way that you can submit it. In some cases, you can submit it to the national coordinator directly. In some cases, there's going to be a local officer of your club if you're a club member, and that you can go to that way. I think by looking on the website, there are actually some programs you can submit to someone who has already done the program, so it doesn't have to be the coordinator or somebody locally. Okay. And the truth is, don't ever send your original paper logs to the person who's going to look at the stuff, because in all likelihood, they won't be returned. Okay, now the big time question here is, when do you log? How much do you log when you do it? Truthfully, most of our programs are done at night, out in the dark, frequently in the cold or the damp. And so the question is, when you're out there in the field, how complete should you be? Should you take the time to sit down and write it all out by hand or type it all in? I will tell you a somewhat humorous story of a guy in the local club here who was really, really cold, and he decided the way that he could do it is he could type everything on a computer, but his fingers were going to be cold. So he had an electric heater blowing across his computer keyboard. He turned away for a few minutes, and when he came back, it had melted the keys off his keyboard. So, you got to make sure a little bit about how much do you want to type? How much do you want to do right there at the keyboard? Can you do it in shorthand? Can you take a little few notes or something like that? Ultimately, how much do you have to do? It doesn't have to be in the final finished copy as you leave that night. After the session, though, you do have to ask yourself, how much work do you want to put yourself into? One of the guys locally here, and I'll talk about it more on a slide here in just a second, but he has one of those little dictaphone kind of things, for lack of modern terminology, and he dictates all of his notes. But that means that he has to, the next day or reasonably soon, go through the process of listening and typing and listening and typing and listening and typing. In last century, that was all set up. That's how secretaries did a lot of things. But today it's like, and so you have to worry about that. One of the questions you need to worry about is, how are you going to keep your log physically? Around the screen, there's some pictures, and starting in the 1 o'clock position, you can do it with a paper kind of log. And paper logs are good. People have used paper logs probably for centuries. The only problems with paper logs is they're hard to see in the dark. And what happens if you are in central Missouri or Arkansas and you have one of our typical dewy nights? After a while, your pen won't write on the paper anymore because the paper's too wet. You can do it electronically with a little dictation kind of device, and I've got that picture there. That's really, really good to use with the eyepiece. It's not going to spoil your night vision, but at the same time, that does usually mean later you've got to listen to all of that and play a sentence, type a sentence, play a little, type a little, play a little. So that can be a little inconvenient for you. You may want to try to type something into a document or a spreadsheet. I actually will admit that I use a spreadsheet to do that. Ultimately, if you're going to have a cell phone, you can, dictate into a cell phone, and sometimes cell phones can do voice to text. Though voice to text and astronomy words don't always work out. Somehow, I'm not sure that if you would say Beetlejuice, it would turn out being spelled anywhere close to where it was supposed to be. I would tell you that a number of programs can have logging kinds of features, things that you can do. Sky Safari is one that I've used in the past, and it does have the ability to do logs. On my Android phone, there's voice to text, and so I can actually do some voice to text into it, and that works sort of okay. I do have to do a lot of editing the next day. One of the problems is a lot of the new people who are trying to do this always want to figure out, well, what is it that they should put in the log? What do they include? A first truth that I would say is that everybody sees something different. If everybody tonight would go out and look at the same object with the same equipment from the same locations, everybody's going to see, the object, but there's other things that are going to be there. So everybody's log should be a little bit different. And so the truth is, you can't have and do it exactly the same way as everybody else. So the Astronomical League does make some suggestions about what you can put in the logs. Now, these are going to be the Astronomical League suggestions. I've got some I personally use, and I'm going to stick those on a little bit here in the end. Okay, but they would like to know, is it round or oval or regular? If it's oval, is it stretched out? How much? The truth is, if you're good and you know what your field of view is, you can actually estimate the size of the object based on your field of view. If it's a galaxy or a nebula, does it have sharp edges or does it fade gradually? If it's a galaxy, does it have a bright core or is it spread out? For globular clusters, is the central area large and full or very pointed? That has to do with Shapley-Sawyer, which is something you have to report. This is the second and final page for this. It says for open clusters, are there stars of the same magnitude? Can you kind of guess the number of stars? I'll throw it in and say, is it kind of condensed kind of structures? Is it spread out randomly? And that kind of has to do with the Trumpler estimations you have to do for that program. Does the open cluster stand out well against a starry background, or is it really hard to pick out? A lot of them in an open cluster program are hard to pick out. I would testify to that. For the nebula, denser, lighter areas, What else do you find in the field of view that's interesting? What else is this cool? Is there a neat double star? Is there a neat kind of pattern? Is there anything that looks like an asterism? One of my favorites is, did a satellite pass through? To this day, I remember probably 2012 working on the binocular double star program. I saw a double satellite, a tandem satellite going through my binoculars. That scared me. I didn't know. And then the truth is, and I don't know if that bottom line is chopped off. It is on my screen. But is there anything else? Make it yours. Put in your own observations. Now, these are the kind of things that I sat down with, and I tried to say, what possible things could I want to put in a log that I'm going to submit, a log that I'm going to keep? I would truthfully say anything yellow there is generally going to be required by the Astronomical League. They're going to want to know the date. They're going to want to know the time. They're going to want to know the location. A lot of times the programs say, latitude, longitude. If you put in, hey, I observed from Bromelsic Park, I saw this from Bromelsic Park, you can go on later and, say the latitude, longitude for that. One thing that they don't ask about is they don't ask about the mount. I've got a couple of different telescopes. I've got a couple of different mounts. Some are equatorial. Some are alt-as. If you're going to do star hopping, it's going to make a difference which one you're going to use because you would attack it a different kind of way. So include information about your mount and the optics and what kind of telescope it is, and if you use any filters and what different eyepieces and powers. The Astronomical League almost always wants to know the seeing and the transparency, but that's not so important today with imaging kind of related programs. One of the things they don't ask about, but I think is important, is the moon in the sky? Can you see it? How bright is it? Is it before first quarter? Is it after first quarter? That makes a difference of what you're going to see and how much detail is going to be there. And then obviously the Astronomical League wants to know the written kind of things. So what can you put in observations? Well, obviously a picture is worth 1,000 words, so you can make a sketch of it. Okay. If you do make a sketch, if humanly possible, try to label the directions. North and west is usually what you see. West is easy to figure out if you don't have a tracking telescope. Which way is the field drifting? You just figured out west. If you got a tracking telescope, turn off your motor for a second. You'll know west. And north is just grab your scope and kind of tug it towards Polaris. You'll find out north. Is averted vision required? Do you see anything else important in the eyepiece? If you're star hopping, where did you start? How did you get between the start and your final spot? Are there any kind of interesting marker stars along the way that you could use to plan it? Did you use binoculars? Did it work for binoculars? Did you plan it with binoculars? Can you see the thing in your finder? Is it better at high magnifications or low magnifications? The Astronomical League gives you a lot of times data on an object, like the right essential index, the size, the object type, the brightness. One of the things I think it's important to put down is other names for the item. Because a lot of times Astronomical League programs double up. You will see the same object in multiple programs, but they'll hide it. They may hide it by saying, oh, that's C80. And it's the same thing as Omega Centauri. And if you know both names, you can kind of, put those things together. One thing I think is kind of important is what were the nighttime observing conditions? Was it hot? Was it cold? Was it miserable? In Missouri, how humid was it? Was it windy? Is it dewy? Is it frosty? I think those are important things that you could put down. Effects of filters. Did you see any color? Excuse me. How much of the field of view did the object take up? It's a good thing to estimate. It gives you kind of a verification of did you see everything that you were supposed to see? Ultimately, what are your overall impressions? Did you like it? Did you have a good night that night? So these are all things that I sat down, and it took about a half an hour to come up with that list of things. But I think it's kind of, it gives you a kind of structure to kind of follow. Do you have to write down all those things for all your observations? No, pick and choose, make it your own. Some things are going to be important. Don't arbitrarily go out and say, tonight I have to say, did I see averted vision with everything? Only use it when it's appropriate, okay? Only a couple more slides. I think one thing that I think is really helpful, and I don't know how many people out there in the world know about it, there is something that Aaron Cleveson has put together. Now, Aaron is I'll say, in charge of the observing division. There are other, people at his level, but he's been there the longest. And he happens to have, I believe, a PhD. And so he has a couple of things that he calls What's Up Doc. And there are links to these What's Up documents on the Astronomical League's webpage. Two things in particular. And I will tell you that when you go, it will take you off the AL site and it will go to his observatory site, which is in Houston for a public school district. Okay. Two things. One, first, he's got a thing that's called What's Up Doc, and it's usually a 2-page now PDF that tells what's available in the sky every month in terms of Astronomical League observing programs. He will give you an idea of what meteor showers are, where planets are up there. He will tell you, oh, if you're working on the Messier program, look at these objects. If you're working on the binocular double star program, look on these particular objects. And it's a fun document to read. If you would go to the Astronomical League website now, this month he does have a link, I do believe, that directs you to that thing. He has not done that a whole lot. And so a lot of times you have to go to that URL at the bottom of the page. The second thing he's got is a spreadsheet. And admittedly, he has not kept up with it a whole lot, but still is a really great document. You type in your latitude, you type in your longitude, you type in the time, and it will tell you essentially what's up there in terms of availability for Astronomical League observing programs for that particular night. To me, that's a pretty nice feature. What's even a better feature is it contains over 4,500 different objects that are parts of various Astronomical League observing programs, okay? And ultimately, it gives you a cross-reference. So it will say, oh, well, this object is on the Messier program, and this is also in the Herschel 400, and it's also in the local galaxy group and galactic neighborhood program, and things like that. So that's a really important thing. I will also tell you that it's in a spreadsheet form. And as part of the spreadsheet, he has columns where you can say, this is the date, and this is the time, and this is what I observed, and this is what the seeing in transparency is. And you've got a field there where you can type that information. So you physically can use his spreadsheet to enter that information and to track what you're doing. And I think that's a particularly powerful thing. So I would offer you the URL down at the bottom. Go there and you will get that stuff. Now, I think I have said this already, but feel free to share and edit any of those slides with a member of your club if you would like to do that. If you got any questions, feel free to email me at that email address. And I am the program coordinator for those 3 programs. So if you forget my email address and you want to look it up, just go to the observing part of the Astronomical League's webpage and go down to astronomy before the telescope or radio astronomy or spectroscopy, and my email address is right there. Anybody need to know anything? Well, we don't have a big audience here sitting live, but I would be glad to answer any questions I could. And if you're watching this by streaming, go ahead and drop me an email. And I think I'm done.
Well, Steve, I'm really glad. I did not realize Aaron had that on the website where they had a 4,500 object catalog. I think that's pretty interesting. I will check that out because I've never noticed that.
It's neat. Oh, I guess I could stop sharing. Okay, so yeah, and well, let's be honest. How much of the membership really goes and visits, the Astronomical League's webpage, Yeah. And so it's a case where, well, I'll go look and I'll see, and I drink coffee in the morning and I'll sit in this very chair in this big open room that I'm in, and I'll just kind of fiddle. And I discovered that by fiddling years ago.
Well, I think you're right too on the observed programs. I've always said you learn with the observed programs, but the one thing to remember is you don't have to start where it's really hard. You can start at an easier pace and really get the feel of it. But what I do guarantee you is you will learn something. And as Steve said, with logging this, it helps you retain that, and even if you don't retain it, you have the record of it. But by not just going through and saying, yes, I saw this and yes, I saw that, because you will not remember from that. A lot of people won't. And I've only done a couple observing programs, but from that I did learn, and it was from the logging, and I kept all my logs, and it is amazing what you can learn. And I don't know, you talk about Herschel 400. Only thing I know is it is a tough one. Start with something like the Messier binocular something easy. Get your feet wet. Get used to it. See what you enjoy. Because this can be as hard as you want. These master observers are called master observers for a reason. They know their stuff and they are there to help also. So Steve, thank you so much.
Let me add one thing. And
Sure.
truthfully, one of the Boerner family expressions is there's a reason why the menu in the restaurant has 9 pages. Everybody likes different things. Okay. And if I would quiz all the people here and all the people online, and say, well, what do you get out of astronomy? I get out of astronomy observing programs. I have a friend here who's a very, well, I'll say Dan Croson. He's the photo editor for The Reflector. Dan's an imager. Okay. And Dan looks through my telescope and he says, is it that smudge? And it's like everybody does something different. We all like to do different kinds of things. There are people out there, outreach is their thing. They want to do outreach. But a problem to me with outreach people is that so many never learn anything new to show. They learn their basic, well, this is November, so November means this month I show these things. And they don't have a chance to get out and discover new things to show people. By looking at the Astronomical League observing programs, it gives them an opportunity to discover new territory.
Right. Yeah. Yeah. And that's, I think, what the League is really about, opening up the sky and giving people choices and ways to learn. So, Steve, again, thank you. That was very interesting. I appreciate it.
Once it started working, I apologize.
No problem. It happens.
I shall mute.
It happens to all of us, believe me. All right. Scott, I do have a question for you.
Sure.
When we were at Alcon, you were talking about a reopening or an event that you're getting ready to have. Would you please tell us about it? Because I'm curious.
Well, it's something I wanted to do for a long time. We have, redone. We did some spring cleaning. We pulled out everything out of our showroom, put stuff back in, redecorated, patched holes where we had hung things up and put up new signage and stuff like that. And we decided that we would have an open house event that's going to be August 26th and 27th. Let me just double check those dates. And so we're gonna hopefully flow this all the way out into our parking lot here in Springdale, Arkansas. We're inviting. I've already kind of put the word out to some local astronomy clubs, but any astronomy clubs that are listening to this, if you want to come down here, and if you guys have maybe some equipment that you wanted to trade or swap, we're gonna allow a swap meet to happen, an astronomical swap meet to happen in our parking lot, where you can swap and trade with each other, not with us, but with each other, and it won't cost you a dime. We're not going to take a commission or anything like that. So. But I thought it would be fun, kind of reminiscent of if you've ever went to the Riverside Telescope Makers Conference. A big part of that conference was a swap meet, and so there would be all these astronomical scroungers out there. People buying mirrors, telescope parts, all kinds of stuff because, well, the Telescope Makers Conference was just that. It was about telescope making, and so. But you can, a lot of times at these swap meets, you can find some fantastic deals. People are offloading their older telescope because they want to get a newer telescope or something different that more or less fits with their observing needs at the time. So anyhow, if you're interested in that, please get in touch with us. You can get directly in touch with me at s@explorescientific.com. We will be putting it up on our website. It's not up there yet because we literally just got permission to do it. So that is, it's going to be fun.
So does that mean the big sale word is there? Are you going to have a lot of sales?
We will bring out our stuff too. Because like every telescope company, we all have like seconds and return, sales samples, stuff like that. Yeah, we're going to sell that stuff. So
I remember standing in line at Riverside waiting to get to the tables. Yeah, and I went home with a lot of
too.
stuff from there.
I was
Yeah,
thinking
I bet
that.
so. I bet so. Well, thank you. I'm curious, is that a Saturday and a Sunday, Scott, or a Friday and a
That is a
Saturday?
Friday, Saturday event. Probably the
Okay.
big day will be Saturday. Yeah.
Big day. Is that probably when the swap meet will be on Saturday? Or will it be
We'll
the
let it
whole?
happen both days,
Okay.
so, you can come here and get warmed up and, if you have a pop-up tent or something like that, you can erect that. We have tables that we can bring out there as well, so,
Okay.
and chairs as well, so it'll be fun. We're even thinking about getting like a kids jumping gym to, try to make it a family deal, so anyhow,
Sounds good.
I'll be
That
in there,
sounds-
but
Yeah.
anyhow.
That sounds good. All right. Yeah, I'm sitting here looking at myself, and everybody's in these nice, cool shirts, and I'm sitting here in a sweater. Now, I'm in
Well, what's
Ohio.
the deal,
It's kind
Terry?
of cool. Yeah, it's cooler here, and I am planning on going out, even though there's full moon. I'm going to go sit under the stars tonight and see if I can see any of the Perseid meteor shower. I know the moon will take
Huh.
out most of them, but I enjoy just kind of sitting out watching the sky. So that is why I look like Nanook from the north here. I'm totally in turtleneck and ready to go out once we get finished. It won't even be dark here at that point, though. So, Scott, how about if it's okay with Bob, can we take a 10-minute break here and get everything switched and ready to go and give people a little bit of break? And we will come back with Bob Anderson.
Sure. Okay,
Okay.
we'll do that. Okay.
Thank you very much, and we will be back very shortly.
This is Richard Hollingham for ESA at the Royal Observatory of Belgium in Brussels.
For more than a century, scientists have been making observations on this site using telescopes like this, still in use today. In fact, this is the World Data Centre for the Sunspot Index. Now though, Solar Orbiter is giving us a whole new perspective of our nearest star.
Solar Orbiter was launched from Cape Canaveral, Florida in February 2020. The spacecraft has since travelled some 2.5 billion kilometres, made 2 passes of Venus to get a better view of the Sun's poles, and 1 pass of the Earth. Now it's just made its first close approach to the Sun, taking it within the orbit of Mercury. During temperatures of some 500 degrees Celsius, the pictures Solar Orbiter's returning show this atomic furnace in unprecedented detail.
I was personally blown away by the quality and degree of detail in these images. And clearly, as solar physicists, we've been looking at images of the Sun for many years. But by going 3 times closer, we can get the spatial resolution up by a factor of 3. And we see things that we haven't seen before. And that's, of course, the beauty of science, to explore the unexplored.
These new images were captured by a camera called the Extreme Ultraviolet Imager, led by the team based here in Brussels.
It sometimes happens, I get into my office, I download the latest data and I stare for hours at it. It's so addictive actually.
The images show activity in the outer layers of the solar atmosphere and reveal a variety of features, including something scientists are nicknaming the hedgehog. It has a multitude of spikes of hot gas reaching out in all directions.
Nobody has ever seen the details of the corona in that much detail before. So every time we get an image down, it's the first time we see something at that scale, and that's really fascinating. It's really discovery space that we're entering.
The Extreme Ultraviolet Imager is one of 10 science instruments on Solar Orbiter, now all working together for the first time. Some are looking at the Sun, others are measuring the environment around the spacecraft. All this activity is being coordinated at the European Space Astronomy Centre in Madrid.
It's important to have all the instruments working and operating in a coordinated way, because one of the main goals of the mission is to link the Sun and its activity with the environment, and not only the environment close by, but also the planets. And for that we want to look at the Sun's activity, at the solar activity, with many different telescopes that look at it in different wavelengths. So that means they are looking at different layers in the atmosphere, and they can also measure things like the magnetic fields on the Sun.
The influence of solar activity, particularly on the Earth, is known as space weather. It includes the effects of the stream of charged particles the Sun emits, the solar wind, and more dramatic events such as solar flares.
So do you think that would be a good target for Solar Orbiter to point at this active region?
As it happens, Solar Orbiter observed several flares and even a coronal mass ejection, all tracked from here in Belgium at ESA's Space Weather Coordination Centre.
Solar Orbiter is basically a research mission, but ultimately we want to be able to predict space weather. These are energetic events that could have an impact on high-tech installations on Earth, GPS satellites, power grids, and we want to make sure that in the future we can predict geomagnetic storms based on solar activity. And for that we really need to take the Sun's temperature and measure the solar wind and connect the two.
Scientists across Europe and ESA's partners around the world are now working to interpret the vast amount of information Solar Orbiter is sending back. And this is just the start of a mission that promises to transform our understanding of our nearest star.
Well, I hope you guys enjoyed that little break. Up next is our speaker, Bob. Bob, the last name.
Anderson.
It's okay, Scott.
God,
Yeah,
I'm so terrible at names. It just says Bob up there, so.
I got this.
Okay, you got this. All right, well, great.
I got it.
Here we go.
Okay.
Here we go. Thank you,
Scott.
Terry.
That was a very good video. So up next is our keynote speaker. His name is Bob Anderson. Bob has had an interest in the stars since childhood. I can relate to that. I was the same way. After working in electric power plants for 24 years as an engineer, he was able to merge his profession with his passion as chief telescope engineer at Green Bank Observatory for 18 years. He retired last year and now tries to observe the sun in both white light and hydrogen alpha light. He is a member of the Astronomical League as a member at large. And I got to know Bob down at StarQuest. He gave an amazing talk on the sun. And I asked him to come on the show and give the talk about the sun because, as I mentioned yesterday on the GSP, we've got 2 solar eclipses coming up. And I think we're going to hear a lot about the sun and a lot about the annular eclipse in 2023 and the total in 2024. So, and on the AL Live, you'll start seeing some about the sun and helping everybody to get prepared for viewing the eclipses. So, Bob, thank you very much for coming on and agreeing to talk.
Well, I feel a little bit overwhelmed with all of you on here, and I'm just an amateur astronomer that has had a passion for the stars. Alan Shepard was launched on my 6th birthday. You can figure all that out. He did a 15-minute suborbital flight over the Atlantic. I looked for him all day long to fly over the house. So, but that launched me into having an interest in space flight, and then subsequently into the stars and everything that was going on. And so after a while, my mom and dad gave me a telescope for Christmas one year, and the local astronomy club had a telescope workshop after Christmas, and I went and visited with them. And of course, they told me what I could see with my little telescope, and gave me a couple of back copies of Sky and Telescope, and then also an application blank. And so that launched me into a lot of things. And I have been in different clubs down in Tennessee. Where I live now in West Virginia is 2 hours to the closest astronomy club. So there's a number of us that share online and through email the goings on that we're involved in. I've done a lot of outreach, given planetarium talks when I was young, and then Halley's Comet came along, and we did a tremendous amount of outreach with Halley's Comet. And then in 1970, there was a partial eclipse that went over our home in Tennessee, and I went and Googled in the public library. You know how that works, and probably a Patrick Moore book that it gave a chart of when eclipses would come through Tennessee again. And so I knew back in 1970 that one was going to come in 2017. And so I've been looking forward to that, most of my life to see that one. And then the follow-up one that's coming in 2024. I've seen actually 2 total eclipses, 2 annular, and I don't know how many partial solar eclipses. I am interested in the night sky, but about 25 years ago, the Bays Mountain Astronomy Club in Kingsport, Tennessee, had an active group that did solar observing twice a month on Sundays. And I got into that, and they had a hydrogen alpha filter, and I really just got into that and wound up getting my own secondhand one, and have had it now for 20-something years, using it in conjunction with white light filters as well. And so there's a lot to be said for solar observing. It's not a replacement for the night sky, but it's complementary. And so there's times when you get clouded out at night, but you can see during the daytime. And it's a whole lot easier to keep your log sheets, Steve, in the daylight. The problem is that the sweat drops off and soaks the paper, and it's just as bad as humidity. So I've got some slides to share that, as Terry said, I shared at at StarQuest, and my wife's over here listening in the background too. So, moral support. Okay, this should work. Okay, so now you should see slides, right?
Yes.
Okay, so here we go. The nice thing that happens is that it's a daytime event, and you can share it with a lot of people. So if you have a big politician or a corporate executive visit you, there will be a document generated called the 5 W's: who, what, when, where, and why. And so I did that for the StarQuest people, and I'm going to do it for you now. Why? The sun is dynamic. The view changes within 10 minutes. It is easier for non-astronomers to see features than most nighttime objects. You know, you show them a nebula in the eyepiece, and they say, well, where is it? You know, I can't see it. And so, but the sun, it's definitely easier to see. Another reason is that you're doing it in the daytime. And this is particularly important with school groups. Teachers, you know, they've had enough of our kids after 8 hours, and they're not willing to come back out. Students, it's hard to get them out. It's hard to get parents interested in bringing their students out for a lot of things. And so, but you can go to the school and offer your, you know, say, hey, I can have an outreach event here with you if you're interested, and you know, let me know during the year when it comes up, and I'll be there, and we can go out and look. So that's a big outreach thing if you want to do it. Anyone with the proper equipment. The sun is dangerous. You don't want to look at it with your naked eye and stare at it. You don't want to turn your telescope toward the sun without a proper filter. And there's lots of people that offer these for sale, including Explore Scientific, and they're relatively inexpensive. When I was young, I'll get to another part of that in a minute, but you could buy Mylar film and make your own holder cap and put it over the end of your telescope, and it was fairly flimsy. Now people are making pretty decent caps, you know, sized for your image, for your telescope, and it has quality Mylar in it that's pretty durable, and it's all cheap. Well, inexpensive. So when, anytime the sun is visible, if it's hazy, it's kind of difficult to see the sunspots and other features on the sun. Everybody experiences turbulence in the nighttime sky. Seeing can be bad if you're in a windy or a turbulent location. Same thing with the sun. The best time to look is mid-morning. It's hard when you're working. It's easier when you're retired or on weekends to get out, you know, 9, 10 o'clock when the sun's up above the horizon, but hasn't started heating the ground around you yet. Don't go out in your driveway or next to the street and try to observe. There's a lot of turbulence there, and you'll wind up having, you know, frustrations with trying to see fine detail. The same reason, avoid looking over buildings. The best area is to look over grassy fields or down by lakes. There's several observatories that are positioned near a lake so that they can observe the sun over the lake. And that's a body that doesn't heat up as fast as grassy fields do even. Okay, so what are we looking for? Well, the first thing is you go out and you look at the sky like we all do, and you can see haze in the sky, you can see clouds and all that. But if you look near the sun, you can see sundogs, you can see pillars, other things that are caused by high altitude clouds in Earth's atmosphere, and you can notice those. Through a telescope with a proper filter, you can see sunspots. You can see the surface of the sun, which looks sort of like the skin of an orange. Through hydrogen alpha light, you can see prominences on the edge, and then filaments on the surface. And you can see flares and a lot of detail around the sunspots themselves. So what drives the sun? Everybody has heard that 4 hydrogen nuclei form 1 helium nuclei, and energy is given off in the process. And so it is nuclear fusion. The cycle, and I think this stuff is kind of important. If you're, a lot of people have a solar filter and they'll say, hey, you want to come look at the sun? And they show them, and they don't have a whole lot of information other than, hey, there's some sunspots there. And so if you have some, for curious people or children particularly that ask, how does this work? 2 protons do combine, and in the process, they give off a neutrino, which is a particle that you've heard of. They also cause an electron to have a positive charge, or a positron. The resulting combination then is a hydrogen proton with a neutron. And then it gets whacked by another proton. And from that, then, that reaction gives off a gamma ray. And a gamma ray is the most high energy packet of energy that we know. If you start at the other end of the spectrum, you have radio waves, and then microwaves, and then the infrared, and then visible light, the ultraviolet, X-rays, and then ultimately gamma rays. These gamma rays fly off in this reaction. And from that, then, you get a helium nucleus, which has 2 protons, but it also has this extra neutron. And somewhere in the core nearby is another set of 2 protons that are reacting. They give off another gamma ray. They form another helium nucleus, and those 2 whack together. And if you count all your protons there, the little red dots, you'll see that there's too many, and 2 of them fly off, and you're left with a helium nucleus that has 2 protons and 2 neutrons. Now, these don't have any electrons because the core has, it's a tremendously hot plasma that, where all this is taking place, 27 million degrees Fahrenheit. We have nothing to compare with that here on Earth. And they're building a facility in France called the ITER, I-T-E-R, and it will be a fusion machine, they hope, and it's going to be even hotter than that, so that they can force this fusion reaction to occur. And so all this happens in the core. All these reactions happen in the core. And then from there out, it's just heat transfer. The first area is called the radiation zone, where energy is being transmitted. These gamma rays are trying to work their way through that. They go up, they go down, they go sideways, they change, they become X-rays or even cooler. And ultimately, some sources say as much as 100,000 years it takes for energy to get from the core to the edge of the radiative zone. And so from there, then, above that is the convection zone. And this is kind of what we think of when air is circulating around us. That's convection. If you are sitting in front of a heater and trying to do your notes at night, then that's generally radiative heat. Sometimes they have convection fans with them as well. But the convection is carrying heat up and down, and it's getting cooler along the way. The core is at 27 million degrees. The convection zone is gradually cooling, and it also has magnetic loops in it. And we see that because the sun is spinning quite rapidly. The diameter of the sun is about 880,000 miles, and it orbits, it rotates once in 27 days or so, depending on the latitude. And so the magnetic field of the sun gets twisted, and you wind up with these loops there in the convective zone. So finally, the gas, the energy cools enough to where it gets back into the light realm, where we can actually see it. Out of the X-ray and ultraviolet and gamma rays back to the visible light. And that point, it's not a true surface, but it's where light becomes visible. It's called the photosphere. And that's where sunspots reside. And above that then is the chromosphere, where you can view features in hydrogen alpha light. Amateurs generally cannot see the corona except at solar eclipses. I was part of a project back in 2017 that 68 of us, 68 stations from coast to coast made a video of the corona. And so that was a very fun thing to be part of. But under normal circumstances, amateurs don't have X-ray telescopes or other means to see the corona. So I didn't include that in this. Okay, sunspots. They lie in the photosphere, as I said. They are dark because they're cooler than the surrounding gas. You can also see granulation, which is that mottled skin of an orange type feature. Or some people say it looks like grains of rice if you up the magnification enough. These sunspots are big. Some of the ones that are on the surface of the sun, if you go to spaceweather.com today, most of those are fairly small, but some of them can become bigger than the planet Jupiter for comparison. Most of the ones that you can see with a decent sized telescope are Earth-sized. So how does this occur? The surface of the sun has cooled from 27 million degrees in the core. It cools to about 11,000 Fahrenheit or 5,800 Kelvin. A sunspot is 1,000 degrees or so cooler. And so if we didn't have the photosphere, the surface of the sun to look at, you were just looking at a sunspot, it'd be very bright in the sky. And so, but by comparison with the photosphere, it's dark and shows up that way. They're caused by the magnetic fields getting twisted. You can see in this illustration that the magnetic field is coming out through one hole, if you will, in the photosphere and going back in another. Sometimes they just come out through a hole and they connect somewhere else out in the corona. So it's difficult to, you can see single spots, you can see pairs of spots. So this one has a north and a south pole, and it's called bipolar. And so you can have a unipolar one, which would be just one spot. Okay, so the equipment that you need are to just see sunspots in the surface of the sun is a white light filter. These are caps that can be made out of metal or plastic. Some of them are fabricated out of cardboard and coated. This filters out the dangerous rays and also reduces the brightness. A white light filter is just taking the whole amount of light and suppressing it downward, and also cutting out the ultraviolet and the infrared. They can be made, most of the ones now are made out of plastic, out of mylar. There's a few glass ones out there still, but it's hard to get a piece of quality glass big enough to go over the front of a telescope. So they're kind of expensive. So the mylar quality has just, in the past 40 years or more, has just improved greatly. It covers the front telescope lens. Now you can get them to fit a refractor. You can get them to cover a reflector. They'd be much bigger for a reflector. They are plastic. They can get scratched. If you live out in the Midwest, I hear it's pretty humid out there, according to you guys. And you get moisture on your filter. You have dust blowing around. And pretty soon you get some caustic or acidic particles that will cause pinholes to occur. If that happens, you just need to buy a new one. I've heard of people trying to cover them with something to cover the little pinholes, but I would feel that it's not worth the risk for that. They're available for cameras. You can buy 2 to go on a pair of binoculars. You can buy single ones to go over a camera. You just have to know your outside barrel diameter. Okay, never, ever, ever, ever use that little filter there on the right. They still make these. They still sell these. They put them in with little refractors that you buy at department stores or Walmart or wherever. They screw onto the back end of your eyepiece. The problem is that the objective lens is bringing all the light, including the infrared, to a focus, and that filter, and I've seen one of these ages ago that was overheated and shattered. And so, fortunately, that guy said nobody was looking through it at the time. And so if you find one of those, encourage the owner to throw it away or smash it with a hammer or both and get rid of it. So you want to use things that are made specifically to look at the sun. Don't try to do it with sunglasses, particularly when looking through a telescope. In the old days, we would take welding glass, the number 14 or welding glass, and use that, hold it over the eyepiece. You can still do that. Anybody who remembers what film is, they would take it and overexpose it and make a filter out of that. And somebody else said that they would take microscope slides and hold them over a flame until they got soot on them. But you can imagine how variable the quality of that would be. And so, the filters are inexpensive enough now to just go get one and use it instead. But don't use any, there's a lot of different types of Mylar. Don't use any that's not made specifically. Go to a telescope dealer and get something that's specifically made for solar observing. Okay, another method is the projection method. You can make a camera out of a shoebox. I've seen that work. There are special sun spotter instruments. The one on the lower right there has a hole. There's a mirror at the right-hand side of it. It bounces it up and reflects it through a lens that projects it on that flat stage there. You can put a sheet of paper on there. You can have people draw sunspots on there as they see them, or you can make a log yourself from that. I don't, other than those 2 methods, I don't recommend using a telescope and an eyepiece to project onto a sheet of paper or something like that. There's a lot of risk there. Older eyepieces had a lot of glued elements, particularly in the field lenses. The pieces of glass would be glued together. Somebody else brought one time that they'd been using that and it popped. And there's no getting that back together again. I don't know how modern eyepieces are as far as the glue and all goes, but I just don't recommend that. And some people will counter that and say, well, it helps you to be able to show a large group of people the sun. And I've had filters. I have people, and you have to be able to talk to people as they're, it's one person's looking through. You tell them and you describe what they're seeing. I take a visual aid, a poster of the sun, and explain to people what they're seeing as they're waiting their turn to look. I've not had any problem with having people look through a telescope and see sunspots or hydrogen alpha features. There's just too much risk. I've had kids and others, they see the light coming out of the eyepiece and they try to look through it, and that's kind of dangerous too. So I just don't recommend doing that. It's too easy. If you really want to do it, then and show a group all together and talk, then get a planetary imager and use it and display it on a computer screen if you want to do that. You never ever use a reflecting telescope for projection, because the secondary mirror can become overheated and shatter as well. And there may be some pushback in the comments on that, but that's, I just don't recommend it. There's too many other ways to do it. There's also a device called a Herschel wedge. It's named after William Herschel, that just uses an uncoated piece of glass to reflect sun's light into an eyepiece. The rest of the heat and light goes out the back end, and you can see one on the right there. These are being manufactured more lately now over in Europe. There's several people over there that are using. You still have to have additional filters, such as several neutral density and an infrared blocking filter. In conjunction with that, you just simply can't use it, because it's still, even with just an uncoated, unaluminized piece of glass, the amount of sunlight that's coming off of that surface is just tremendous. Again, you don't use that with a reflecting telescope. Here in the United States, I don't know about over in Europe, but here in the United States, solar filters are less expensive. And unless you're just doing high quality photography, they're just as good. Solar filters are just as good for visual observing. So what can you see in sunspots? You'll see a dark area. That's the center of it. That's called the umbra. And then surrounding that is a lighter area called the penumbra. They're usually grouped. There'll be a positive sunspot and a negative where the magnetic field is coming out and going back in. There are light bridges where you can, which is a little bit of the white there that you can see. I don't know if you can see my cursor or not, but this is a light bridge going across this umbra here. And then around it are other features. So now I'm not a paid spokesman for the Astronomical League, but there are two solar observing programs. One is the SunSpotter, which is white light, and the other is the hydrogen alpha, which you have to have a hydrogen alpha filter for. And so the SunSpotter program gets you familiar with the sun. You have to observe it for several weeks, or I can't remember exactly how many observations you have to make, but it may take a couple of months to be able to do that. You sketch the sunspots. You have to classify them, and I'll tell you a little bit about that in a little bit. Artistic ability is not required. It says that in the program. You submit copies of your observations and your independent certificate, and you become more familiar with the sun and personal satisfaction. Sunspot cycles, everyone knows that we're going into a maximum. Should be a very interesting eclipse if we can see it at sunspot maximum. So classifying these, there's information in the SunSpotter program webpage that tells you how to classify them. These are real. They're used by professional astronomers. You can go to solarmonitor.org, and after you make your classifications, you can compare it to what they say. And if you want to look in the back of the book for the answer, that's sort of like what you're doing there. Okay, so I've taken the SunSpotter sheet and the hydrogen alpha sheet, and I kind of combined them a little bit so that I could collect the information for the way I observe, but there is a specific log sheet for each program. And as Steve said earlier, there's a lot of information you have to compile about transparency and seeing. A lot of times you can see the sun through haze, but if it gets too thick, then you lose track of that and can't. On spaceweather.com, there is a sunspot number, and that is actually called the Wolf number. you count the number of groups of sunspots, and then you count the individual sunspots. You take the groups and you multiply by 10, and then you add the number of sunspots, and that gives a number. And so you can compare your number then to what spaceweather.org has. You also put down the Carrington cycle. Richard Carrington was an astronomer that lived in the early 1800s. He identified the sunspot cycle, and he started with cycle number 1. And right now, I think we're up to 2260, if I remember correctly. This is my log sheet from the first day of summer, June 21st. And it shows both sunspots and hydrogen alpha features like prominences. And then later that day, I, through another telescope, took a white light image. And I'm a visual astronomer. I dabble a little bit with photography. Being an engineer, I'm a gearhead as well. But that's the 3 different flavors of amateur astronomers. And professional astronomers are the same way. Having worked at an observatory, I know that some of them are just focused on developing equipment, the latest receiver. And so I like to do a little bit of all 3. And I think many amateur astronomers are the same way. Okay, now let's go to hydrogen alpha. For hydrogen alpha, you're looking at the chromosphere, which is a very thin layer. Remember, I said that the sun is 880,000 miles in diameter. The chromosphere is only 1,200 miles thick. It is visible in the light emitted by the hydrogen atom as one of its electrons loses energy and drops to a lower energy level. That energy is given off as light, and it is centered on a wavelength in the red part of the spectrum that it's not invisible, but there's a whole lot of other light in the background that wipes us out, and we can't see it unless we have a special filter. So it's the visible spectrum goes from like 400 or 4,000 angstroms, which is 10 to the minus 10 meters. It goes from 4,000 in the violet to about 7,000 in the red, and that's the visible range. And you say the hydrogen alpha wavelength is centered right at 6562, so that's very close to the edge of what we can see. So a hydrogen alpha filter is manufactured. They take either 2 pieces of glass or 1 slice of high quality mica, and they do electrical depositing of a thin coating on both sides of the mica or on one side each of a piece of glass. And then they put them together. There's spacers in there. And so the light actually is going between the grains of the coating. And once it gets inside there, it bounces off the other and bounces back and forth. And the light then will cancel out some wavelengths and it'll reinforce the others. And so this is an interference filter. It's positive and negative interference. It builds or it tears down. And so the ultimate product is light that comes out through the grains in the other coating. And we see that at the infrared or near the infrared at the hydrogen alpha wavelength. There's always a way to tune these. There's several different manufacturers. I guess the oldest is the Daystar filters. They heat this optic package to a set temperature that allows the hydrogen alpha light to come through. There are other designs that actually tilt one of the pieces of glass that allows the light to come through, and that's how you tune it. There's a third method where they have a pressure cavity, and you're just by turning the knob on the side of the eyepiece or filter, it's adjusting the pressure. of the cavity and allows the spacing of the glass to change. Okay, so here's an illustration. I drew this on the board at StarQuest, but I couldn't do that for you guys. So the wavelength of hydrogen alpha is 6562.8. That's that center line. And the filter then gives a area around that wavelength that passes the light through. It's not a straight shape. And so there's a trimming filter that's put on there to cut off the bottom part of it. And what you're actually doing is cutting out light from the photosphere. And so if you can cut that out, then you can see the features in the chromosphere above it. They'll call that width of the either the bandwidth or the bandpass. The technical name is the full width half max value. And so if the light coming through the filter is 100%, you measure this at the 50% level, which is the full width half maximum width. And I'll get to that in just a second, how that works. In addition to just the glass etalons that are the interference part of it, you have that trimming filter that cuts off those feet. You have a blocking filter also, and maybe two blocking filters that remove everything else and the ultraviolet and the infrared that can damage your eyes. Okay, this knob or buttons on the side of the filter, you're adjusting the tilt, the pressure, or the temperature of the filter, and you're actually sliding the filtering pass to the left or the right, either towards the red or towards the blue. And this allows you to do a couple of different things. One, your filter is going to heat up, your telescope's going to heat up, and it's going to get off wavelength. And so you have to adjust that as time goes by. The other aspect is that 880,000 diameter sun, if you look at the very edge, at the east or the west limb, you either have features moving at you tremendously fast or moving away from you tremendously fast. And so you can tune your filter to actually bring the limbs, depending on which limb you're looking at, into focus. The other aspect is that if you tune it to where you're looking more down into the red, you're looking deeper into the chromosphere near the surface of the sun, the photosphere. If you tune it towards the blue, you're looking towards the top of the photosphere or chromosphere. And so you can kind of see different features that we'll talk about that in just a second. But you can, depending on where you're looking on the sun, you can see vertically or you can see better to the limb. Okay, so prominences. Sometimes people call these flares, but the technical name is a prominence. They appear on the limb of the sun. That is hot gas that is following the magnetic field lines from one spot to another on the sun. And so they stand out starkly from the sun. They're very easy to see in the hydrogen alpha. If you want to see the prominences, you only need that bandwidth to be about 1 angstrom, 10 to the minus 10th meter. If you want to see granulation, the surface near the photosphere, you have to get it down to 0.5 or 0.3 angstroms. The problem is that you're cutting out more light, and so the prominences tend to look fainter. And so a good compromise is usually about 0.7 or 0.8, and you'll see manufacturers making filters to that bandpass, and that gives you a good view of both the prominences and the surface stuff that you see. The sunspots, the very small ones particularly, get tuned out because you're looking at almost, you remember this is kind of like, the atmosphere. You're actually seeing clouds of gas over the sunspots, and they get kind of masked. So who makes these? The Daystar company makes heated filters. You have to have an electrical source. Mine is pretty old. It has to run on 120 volts. The newer ones, I think, run on 5 volts and can actually be powered by a USB cord. The tilting filters are made by Coronado, Lunt, Orion. Orion's is only for prominences. The Coronado and Lunt filters are actually, you can see surface features as well. Lunt also makes that pressure adjusted filter. They all make dedicated solar telescopes. And these are telescopes that cannot be used for nighttime observing, because those different interference filter and blocking filter and trimming filters are all made into the barrel of the telescope, or even into the diagonal on the back end of the telescope. So they are solely for solar observing. All right, Steve, I'm having trouble. There. Okay, so what can you see? A prominence is on the limb of the sun. The filaments or prominences that you're seeing on the surface of the sun, just looking straight down on them. Plage is the French word for beaches, and these are the areas around sunspots, and you can certainly see those very well. They'll be brighter around the sunspot. You can also see these bright areas away from the sunspots. Flares are short-lived bright spots. You'll see an eruption where all these magnetic field lines will get twisted and they'll snap, and some gas will shoot up out of the surface of the sun, and that's a flare. And then you can also see connections between sunspots, the dark filaments and also the brighter areas. And it's just, stuff changes just so fast on the sun. The only other object in the sky that changes that much is Jupiter. You can see changes over hours on Jupiter. You can see rotation in just a little bit, but the sun is far more dynamic than Jupiter. There is another observing program called the Hydrogen Alpha Observing Program. Again, you have to observe for several weeks and make sketches or photographs. You have to submit copies of your observations, and I really enjoyed both of these programs and going through those almost as much as I did the Messier program. Okay, now how do I observe? Now remember, I have an older Daystar and I have to plug it in to warm it up. You can do the same thing with the other manufacturers' filters, but you have to tune them off and on to wavelength. So the first thing I do in the morning is, look at the news, look at the weather, and I go to spaceweather.com and to see what they're seeing. Now, these images that they post and the sunspots that they illustrate are hours old. By the time I get out mid-morning or later in the day to observe, the sun's changed. And so sunspots disappear, sunspots appear, and they also move as the sun rotates. So then I go out and look at the sky. I do not look directly at the sun. I block it with my hand or a tree or the building or whatever, and just look to see what Earth's atmosphere is doing around the sun. And then I view the sun in white light. I sketch it. I count the sun. I don't count the sunspots directly from the sun. I mark them on my piece of paper, on my form, and then I count them on the form. And then I'll go back to the sun and I'll look again, see if I, invariably I've missed some, and I'll go back and fill them in. And then I fill in all the log information that's required for that. And so one thing that Steve mentioned was logging the time to the minute. I generally log the time I begin my observation. Others may log the time that they end, or somewhere in the middle, but I generally log it when I begin. Then I turn on the hydrogen alpha filter. It takes about 10 or 15 minutes for that to warm up. And while I'm doing that, I refer back to the sunspotter program information, and I classify the sunspots. And that takes a little bit of time to do that. And then once the hydrogen alpha filter comes on wavelength, I start with the prominences, because they really, you can see a prominence change in 10 minutes. And so I sketch those, and then I go to the filaments over the surface of the sun, the sunspots, trying to illustrate the plage, the bright areas around those. And then after I get all that done and close my observatory back up, I go back in and go to solarmonitor.org and look and see how they classified the sunspots as well. Okay, there's a number of good books out there. One that's, and several of these are out of print now, like Observe and Understand the Sun, but it's been copied and it's on the SunSpotter program. If you look at the reference material in the SunSpotter program, it's there, and you can download that, particularly the classification sheets and the observing conditions sheets, and take those to the telescope with you. That's very helpful, a very big illustration of what the sunspots are supposed to look like. Jamie Jenkins wrote a book in 2009 called The Sun and How to Observe It. You can get it through Springer. I don't know if you can get it through the League bookstore or not. The Observer's Handbook is very useful. It has a big solar section in it. You can use it to get the Carrington cycle number, as well as a listing of features and happenings that are coming up. And then a later one that has just come out in the past couple of years is Solar Astronomy. It was written in French originally. It's a good many of European observers. And this book is like getting a sip of water from a fire hose. It has a tremendous amount of information about not only the sun, but also on the equipment, on how filters are made and quality conditions for those, how to build a dedicated solar telescope. And it's just really good. It's expensive. It was reviewed in Sky and Telescope in, I think it was the August edition. And the guy was very glowing in his praise for that. But Solar Astronomy, if you're really wanting to get into it, that's the book you ought to get. And then of course, the SunSpotter and the Hydrogen Alpha observing programs are also very good. Have a lot of information about the sun. You can also go to Daystar Filters, has a good website, very good website. Spaceweather.com and then solarmonitor.org are also very good. Very good. All right, and so then as Terry alluded, in 2024, we have the opportunity for another eclipse. This one goes at almost right angles to the one in 2017. It starts out in the ocean in the Pacific, goes across Mexico, comes up through Texas, and ultimately winds up out over the Atlantic, over Canada. It goes over across a good portion of the United States. So all of us that lined up east-west for the last one now have to line up south to north and look for a good spot to observe from. And so I would encourage you, after 2017, I don't think the media has gotten a hold of 2024 yet, but when they do, then places are going to get booked up to travel to, campgrounds, hotels, everywhere. So you need to kind of, start now staking out a spot where you're, look at the weather, look at the conditions. This is in April. April is notorious. The further north you go, you might get snow. Further south you go, you may get rain. So you have to be kind of careful as to where you choose. But you need to start thinking about it now. It's only 2 years away. So that concludes what I have to show And I hope that was helpful. I hope you get out and observe the sun yourself, but also share it with others, that you can actually go out and see what's going on.
There we go. Thank you, Bob. That was amazing. Yeah, I think, one thing that does worry me with the 2024 coming up, and Scott and I and a bunch of us have discussed this, sometimes even when you reserve a hotel, Airbnb, whatever it is, way out ahead, once they realize they could have gotten 3 or 4 times the money, they can cancel on you and then up the price. And that is one thing that kind of concerns me, doing that. But one other thing is Scott and Explore Scientific have created the expedition, Crossroads Expedition. Why don't you talk a little bit about that, Scott?
This expedition is going to happen in Hill Country in Texas. So we have secured a private ranch that both eclipses, the 2023 and the 2024, the 2023 annular eclipse and the 2024 total eclipse will cross. And so we'll be posting prices and stuff. What I can tell you right now is that Mickey from Mickey's Kitchen, who supplies culinary treats for the Winter Star Party, is actually going to make the trip all the way out to Texas and set up out there. We are arranging for, because this place is out in the middle of nowhere. So this is going to be a dark sky star party, both of them, okay, and a solar eclipse, okay? So you'll be able to enjoy, low Bortle skies. I think it's Bortle 2 out there. You can see the Milky Way extremely well from our location, and it's about as far south as you can get without going into Mexico. So we will expect in the 2024 eclipse, well, actually both eclipses, I think it's over 4 minutes of duration, and I'm really, I have not successfully seen a annular eclipse, but I'm looking forward to it because, it is a good chance to really examine Bailey's beads. You can see Bailey's beads even on a total, but with an annular, you just got a little bit more time to really check them out. Of course, during an annular eclipse, you're going to be using filters the entire time, so you're going to see all those guys out there with their H-alpha telescopes imaging this and just getting spectacular results. Of course, for the total, a different experience. People use H-alpha, they use white light to observe it, and then when they get to totality, all the filters come off. So practicing for your solar photography is a big deal. You can do that, of course, anytime the sun is out. You're going to want to watch videos by people who are experienced in doing total eclipse photography. So just to kind of get this all in your mind and everything of how to do it. It's real easy to forget, okay, what you're supposed to do when totality happens, because this experience it makes a
mind-blowing
shift in people. They see it.
Yeah.
It's beautiful. I've seen professional astronomers. I was out with, in 1991, I was on Mauna Kea, right in front of the CFHT Observatory, and I watched pros run outside, okay, totally ignoring their equipment, run outside just so they could see it, and their jaws are dropped and everything. So it's staying on the mark and doing what you're supposed to do is real important, especially if you're going to make astrophotographs. If you're not, just watching it visually is a beautiful treat, and so trying to do both is like more difficult than chewing gum and walking at the same time. That's for sure.
My wife and I have seen two solar eclipses. We've seen two annular eclipses, and we've seen two total eclipses.
Okay.
And
Yeah.
I would echo the advice that somebody else gave, and that is for your first eclipse, for your first total eclipse, don't try to do photography.
Just watch it. Yeah.
Just watch it. And
Yeah.
then
That's pretty good advice.
and participating in the Citizen Kate project, they drilled that into us that, hey, you need to, you've had experience, seeing one, you need to focus and you need to do this. And so, and then, we wound up with, I guess, an hour and a half or so of Corona video from coast to coast with all of us doing that.
Yeah, that was
we looked,
Yeah.
it's an amazing event to see, but I was focused on doing that. A lot of people around me whooping and hollering, and you have to watch the time to make sure that you get your filter back on your telescope.
It's true.
When just ahead of when Bailey speeds start.
Yeah, that's right. That's
Yeah.
right. So we have, go ahead, Terry.
I was going to say, can I ask him a quick question? You've already looked. Bob, how often have you seen a light bridge? I have never seen a light bridge, and I would like to.
I see them in white light.
Okay.
And you can kind of see them grow. Most of the ones I've seen were already in place, and then they would dissipate. But it depends on how often you go out and look.
Okay.
I'm trying to go out every day. I don't make it every day, but for weather or personal reasons. But just about every day you can see a light bridge if you watch long enough. And my observations take about an hour.
Okay.
To do. So,
And that's with a white light filter, correct?
yes.
Okay. Okay. Thank you. Okay.
It's a little harder to see in the hydrogen alpha because you're kind of looking down through the chromosphere's haze and fog over the sunspots.
Okay. All right. Thank you.
So Pekka Hautala, watching from Stockholm, Sweden, on Facebook, he says he wants to know about the Lunt HA B600 telescope. I'm not sure how much you know about this particular instrument, Bob, but he says, does additional IR UV cutoff filter after H alpha filtering make any visible change when imaging?
I would say that filter probably already has internal blocking filters in IR and UV.
Mm-hmm.
I don't know that they require one. In addition to that, usually some people will put a neutral density filter behind that, but if he were to go to the manufacturer's website and go to the contact page and ask, they would probably tell him what would he needs to tell them specifically what his telescope is and what filter model he has, like you just did, and then see what they say as to what the best way, and tell them what their camera is too.
Okay. He also has a question. He says, are prominences and perturbances the same? And if not, what's the difference?
I'm not sure where the word perturbance comes. Protrusion maybe, but prominence is what the professionals call the either the pillars or the loops that are on the limb of the sun, and then looking down on top of them, they're called filaments. And the filament can be a small, thin line, or it can be a kind of a hazy, long jet stream looking event on the surface of the sun.
Okay. Everybody else is saying thank you for this great presentation. So
Definitely. All right. Okay. Anybody in here with us have any questions, Steve or Carol or anybody?
I'll just ask Bob if he recognizes the picture behind me.
No. Yeah.
Yeah, I do. It's a Green Bank.
I put that up just for you.
All right. That
was
looks
nice.
like the The 40-foot, isn't it? Yeah.
That's the 40-foot, yeah. I spent 2 nights in there once.
Yeah.
Great presentation, Bob. Well done.
Yes,
Thank you.
thank you. Thank you very much. Very well done. What I would like to do now then is, let's see, I'm going to announce the winners. I'm going to finish with the questions. And one thing I would like to say, thanks everyone. There was a lot of very nice compliments in the answer emails today. They have been really enjoying the presentation, and thank Explore Scientific and the Astronomical League for doing this, and the amazing presenters that we have had tonight. So thank you for all the kind compliments that I received about this program tonight, about everybody involved. So I think I can speak for all of us to say we all enjoy what we do. And we're just really glad that you are enjoying it too. So thank you very much. So let's go back where I'm supposed to be. The answers for tonight. Saturn's rings will be 14 degrees open at opposition on August 14th. How many years will it be before the rings are opening enough to reveal the splendor again? And that is about 5 years. And Josh Kovac got the correct answer. I think I skipped my first question. What is the name of the landing site of the Curiosity landing site? Well, yeah, it is Gale Crater, but they have kind of nicknamed it Bradbury Landing after Ray Bradbury.
Oh.
So, yeah, I was surprised to see that too. Irene Nestor has got that. Last question. What constellation is Comet Pan-STARRS located in on September 15th? And that would be Scorpius. And the people that answered it right was Paul and Kathy Anderson. So if you are one of those 3 people, somebody from the Astronomical League will be contacting you. And I didn't share my screen, did I, Scott?
No, ma'am.
I did not. Let me go just do a real quick so you can see. I got carried away.
Paul and Kathy Anderson live here in Northwest Arkansas. So.
Oh, do they?
Yeah.
Ah,
Hi,
well,
Paul
that's
and Kathy.
nice. Now you know. Okay, so I'm not going to read them all again, but here are our winners again. And then, yeah, Paul. So somebody from the Astronomical League office will be contacting you in the next few days. And thank you very much again for all of the answers. And I would also like to thank Bob Anderson, Steve Boerner, David Levy, Scott Roberts, Carol Orge, all of you for hanging out with us tonight and listening to our talks and listening to us and answering the questions. And again, all the nice compliments. I have never received so many compliments. So guys, you did a great job tonight. Thank you very much. And thank you to everybody that's watching. We couldn't do this without you. And we really hope someday we can meet you in person and see you at an Alcon or at a star party. If we're ever at a star party, please come up to any one of us and introduce yourself and, tell us who you are and that you're interested in astronomy. So the last thing, next month, thanks, Steve. Astronomical League Live will be next month, and my date should be behind the bar here. There we go. September 16th, and we're going to have Brett Maynard. I thought, fall is coming up, and I don't know about you guys, but finally it's going to be cool. The nights hopefully will be clearer. Hopefully we'll be out doing more imaging. So I invited Brett Maynard, and he is going to take us through preparing for a night of image capture. So please join us September 16th at 7 p.m. EDT for that. And I think that ends what I have got. That's it. Okay, anybody else got anything that they would like to say before we sign off?
Well,
this is the most quiet everybody.
Okay, Brett Maynard's a great guy. He will do everybody well.
Yes, Brett is an excellent imager. Unbelievably good. Yes.
I found a good joke about the sun. It says the sun is the real star of our lives because it's the sole reason why life on Earth exists.
Oh, that's nice.
Bad joke.
Thank you, Scott. What a great way to end a solar program.
Okay. Thanks,
right,
everyone.
Scott.
It was fun tonight. Thank you very much.
Thank you, Scott. Thank you,
Yeah.
Carol, Steve, and Bob. I appreciate you being here and all of your expertise. So with that, unless somebody has got something to add, we will go ahead and sign off.
Okay. All
Good
right.
night, everyone.
Night.
Good night.
Here we go. All righty. Thanks again, everyone.
Thanks, Scott.
Hey, Terry,
Hey,
see
Scott,
you
count
next
us in.
summer. Bob, see you next summer.
Yeah. Count us in, Scott.
All right.